Everybody, welcome to my presentation, Introduction to Smart Components. My name is Marlon Banta. I'm a director in the product definition team at the Dassault Systems SolidWorks Corporation. The goal of the presentation is to teach attendees to create smart components from components that they use frequently that require the addition of associated components and features. Our agenda today, we're going to talk about the general concepts of smart components, then we'll get into part one, and there we're going to focus on creating and using smart components. We're going to do our work through the design library, and we'll have two exercises in part one. In part two, we're going to look at how you can take advantage of configurations that you've defined within your smart component so that when you use that smart component, you can select a particular configuration and have the associated features and associated components update with it. And then part three, we're going to look at auto sizing and basically specify a range of values for which an associated feature applies. So when do we use smart components? There's really a broad range of instances where smart components can be applicable, but generally, we would consider smart components when you have a widely used component, and again, a component can be a part or an assembly, that requires the same mounting features and or hardware to be properly assembled. So these are a few examples. So if we look here you have these panel mount switches, right? And if you look at just about any of these panel mount switches, you should see that they have, in their specification, they have information about the holes that need to be cut out, or hole patterns that need to be cut out when you panel mount. So you can imagine having this as your smart component and these cutouts being added when you insert your smart component into an assembly. And of course, here we're looking at speed reducers this is the McMaster car catalog. And so, of course, when you apply this speed reducer, you need surface to accept this flange with these holes in it and also bolts. Maybe you have one of these mounting plates, and so that would be a component that you'd include with your smart component. But basically, when you bring in this speed reducer, you need features to be added to the components to which the speed reducer will be mated, and also the associated components like bolts and gaskets and washers and things like that. In this example, we're looking at a Murphy bed here, and when you buy one of these Murphy bed kits, the only thing it comes with are these hinges and this part here. And you have to apply a very specific hole pattern using the specific hardware that comes with that hinge in order to properly mount the Murphy bed within the frame that you build when you buy one of these kits. Some other examples. So let's say that, I'm very interested in guitars, and if I want to mount this pick guard with these pickups into the guitar, I would need a pattern of holes into which I could add these screws. And I'd also need the screws to add the electronics to the guitar. And here is another example, right? So if our part is this flange, the associated components are all of these threaded studs, the washers, and the nuts. The associated, and as well as this O-ring, and then the associated components are these holes into which the threaded studs are screwed in, and the O-ring groove here in the mounting plate. So anytime you're going to use this pipe flange, the surface onto which the pipe flange is mounted needs to have these holes in this groove, and you need all of these other associated components in order to add this pipe flange. So this would be a great example of where you'd want to accelerate that process using smart components. So there's a general workflow in smart components. Step one is to create a setup subassembly. So this is where you train the smart component. This is where it's like a simple block of wood or something like that. You add all of the mounting features, you assemble all of the mounting hardware, bring all of that together into your setup assembly. And then inside that setup assembly, you would select the Create Smart Component command, and you would identify the smart component, you would identify the associated features and all of the associated components, the hardware, the bolts, things like that, to define your smart component. And then when you insert the smart component into the assembly, you made it into place, you turn on the smart component functionality, and it will ask you, in the case of associated features, it will say, well, which face in your assembly corresponds to this face in the setup assembly? And then you would apply all of the mounting hardware, press OK, and now you have your smart component with all of the associated features and associated components assembled into your assembly. So let's get into, what that means more in part one. So here we're going to show the process of creating and using a smart component. So first, let's come into SolidWorks, and here we're using the latest version of SolidWorks 3D Experience Connected. So this is SolidWorks integrated fully into the 3D Experience platform. And what we want to do is come in here into the design library, and I want to add this folder. In here we have our 4 exercise folders. So the first thing we're going to do is come in here. With these hands-on materials, we have a hands-on session tutorial. What I recommend doing is splitting the screen where you have SOLIDWORKS on one side and this tutorial on another, and you can follow all of the steps here in the tutorial. So here we're talking about adding the Smart Components folder into the design library. And in exercise 1, we're going to use the bed rail fastener. So here is the startup assembly. And we go ahead and drag and drop that into our window. We can see that this is the assembly that we're using to train or to define the smart component. This right here, bed rail fastener, this is the component that we want to be smart. Here are the associated components, these bolts that we want to be included whenever we bring this bed rail fastener into an assembly. And we have defined, let's go ahead and hide this. We've defined this training assembly. And in this wooden block that will not be part of our smart component, we have these features. And these are the features that we want to be added when we bring the bed rail fastener into another assembly. So we go ahead and show that component. Okay. So looking at the instructions, we want to select this, and then we can come into Tools, scroll down here and select Make Smart Component, or I can select this, hit the S key, and Make Smart Component. Search that there. I also have the ability to search for commands up here. So we're going to go ahead and make Smart Component. It pre-selects the bed rail fastener. And then what we want to do is, this is our Smart Component. Then we want to select the associated components. In our situation, it's these 3 bolts. And we want to select the features that will be added into the assembly, the mounting features, when we add the smart component. So in this case, we're going to select these 3 extruded cuts. Hit OK. And then we have to save this setup assembly. So we save that, and now this part we have that little lightning bolt. It is now a smart component. So if we close, we can come in here and let's actually go ahead and mount that smart component. So we have this assembly called headboard. One of the reasons why we're using the design library is that when you drag and drop, it attempts to automatically mate the component. So here we'll add the bed rail fastener here. We're going to go ahead and drag and drop that into place. I don't think we got the mates 100% like we wanted them. So here, there we go. We'll flip that. And then we want to add a couple more mates. So one of the first projects that I had working for SolidWorks was adding the width mate into assemblies. And I really like the width mate because it very quickly aligns the component where you want it to be. We could add additional mates if we wanted. I could add a distance mate to correctly locate this, but we'll just go ahead and have that smart component be there. So now let's activate the smart component. Let's add the associated components. Let's add the required mounting features. One, we could just pick the component here and we get this item right here, insert smart components. Another thing we can do is right click and insert smart features. So either one of those will activate smart components. I like the on-screen shortcut. And so here are all of the features that will be added. Here are all the associated components. And what it's asking us is it's asking us to find the face in our current assembly that corresponds to this face in the training assembly or in the startup assembly. And it will be this face. Press OK. And you can see that here's the smart component. These are the associated components, and we can see that the mounting features have been added. So we've greatly accelerated our design workflow in this case. In a situation where we're always using this component, we always need the same mounting features and the same mounting hardware, we can very quickly add that smart component to any assembly and significantly accelerate our work. So again, this was our training assembly. These were the mounting features. These were the associated components or the mounting hardware. This is the smart component itself. And this wooden block is something that we created, as a base part in order to train the smart component. And so these are the features that we select and the associated components. And of course, when we add it, we see that we have these smart features added to this board component, and we have our smart component added and identified again with this lightning bolt. So let's look at another slightly more complex example, doing essentially the same thing that we did in part one. We have this training assembly. These are our mounting hardware. These are the mounting features. And of course, this is a hinge that goes between the cabinet and a door panel, or two different panels of wood. We'll just close everything. Advance to that part in the tutorial. There we go. And so in this first part, we're looking for the training assembly. And so again, this is the hinge that's our smart component. These are, this is the mounting hardware. And then we have features in both of these panels that we want to be included or added to the assembly when we insert the smart component. So let's go ahead and take this hinge. Sorry, we're gonna hit the S key. Make smart component. Now for the mounting hardware, we're gonna pick those 4 screws. And for the features, we're gonna go into these 2, we'll call them scraps of wood in, oh, that's not what I wanted. Sorry. There you go, those holes. And then we want that big hole in those holes. So we went into the 2 scraps of wood and selected the features that will be added when we add the smart component. And go ahead and hit OK. And we'll hit Control S, or we can say save to this PC. So remember, this is SOLIDWORKS 3D Experience Connected. A very powerful part of SOLIDWORKS 3D Experience Connected is its connection to the 3D Experience platform, which is a data management platform. And I could be saving these files up to the 3D Experience platform for file management, allows for collaboration. It allows you to lock components to indicate whether or not they are in development design or they're ready for production. So the maturity cycle. There are many powerful tools in the 3D Experience platform. For today, we're just going to be saving to our current disk drive. But of course, we encourage everyone to learn more about the 3D Experience platform and explore the powerful tools that we have on the platform. So now we want to find the sample cabinet. And we are going to drag and drop our component that has now been made a smart component. So that is aligned the way we want. Okay, that's, oh, it's actually not the way we want it. Let's rotate this. There we go. That's more like what we want. And of course, we can add mates to more correctly position the smart component. So let's say we want, we're going to add a parallel mate there. And then I'll go ahead and I'll add a distance mate. There we go. And so now we've located our smart component using mates. And we see that this component has that lightning bolt. So when we select it, we have that option to insert all the smart features. And of course, I can come in here and use that command instead to insert the smart features. And it's asking us what are the matching faces in our current assembly. Here's all of the hardware. I'm sorry, all the features that will be added. Here's all the hardware that will be added. So we want to select that face to match here, and then we want to select this face to match there. And again, we see all of the associated components and the required mounting hardware has been added to our assembly with this smart component. Again, here are the mounting features and the mounting hardware for this smart component. So a few guidelines. You cannot use virtual components when you're defining a smart component. And again, a virtual component is a component that exists only in the assembly. Like you haven't saved that component to its own file on disk. And so smart components require all of the associated components be created as not as virtual components, but as components that are saved to disk. No assembly features. Any associated features need to be defined within the parts in the test assembly, and those features will be added to part components in the destination assembly. There should be no external references for the smart component itself. So if you have a component whose length is dependent on the position of another component in an assembly, that would not be a good candidate for a smart component. And let's say that you realize, oh, I forgot to add a bolt, or I want to change the definition of that smart component. I want to add a new feature, things like that. The process for doing that is to open the smart component in its own window. In this case, we'll come here. Oh, sorry. We're going to open the smart component in its own window. We'll go to the smart feature folder right here and edit in defining assembly. And this is why we have to save that defining assembly, right? So that we can get back to it and it is part of the definition of that component. And then we can come here and select edit definition, and I can remove components, or I can add components. I can remove features or add features and change the definition of that smart component. Let's go ahead and close these files. We discard any of those changes. Okay, so that's the end of part 1, exercise 2. And then we're going to move into part 2 to show how we can use configurations to drive our smart components. When we're considering configurations, what you want to do is set up the configurations first for your smart component and define those configurations in your setup assembly. And then when you apply that configuration, or I'm sorry, when you apply the smart component or insert the smart component into an assembly, then you can select the configuration and the associated features and mounting hardware, things like that will be updated based on that configuration. So in this example, we're going to have a motor, and we're going to have a small motor and a big motor. And here you can see in the configuration table that we have a definition for big and small and all of the different definitions for the configuration. So let's get into exercise 2. We're going to come in here, and the assembly we're going to open is motor to teach. So again, this is our training assembly where we define the smart component. So here we have this motor, and this motor has 2 configurations. There's the small configuration and the big configuration. So we see that not only does the size of the motor increase, but also the mounting holes for these mounting bolts will change based on whichever configuration you choose. So the first thing to do is we're going to define the smart component from this setup assembly. So there we're going to select all of this hardware. Yep. All right. And the features are going to be these mounting holes right there. Okay. And then we're going to look at the configuration table. And we see we have big and small, and these are all the components that are associated with each configuration. We're using the same nuts and bolts. They just pass through different holes depending on how we, which configuration we select when we insert the smart component. I'm going to hit OK. And of course, we have to remember to save the smart component. I just did Control S right there. So now let's go ahead and use that smart component. So here we have the assembly into which the smart component will be added. And I'm going to drag and drop this motor into place. And it asks me which configuration to use. I can use small, or big. In this case, let's select big. I may have to move it a little bit. Oh, there we go. We're going to move it into place. And of course, we come here, insert smart features. We're going to insert the mounting features and all the associated components. And it's asking us for this top face, and then it wants the bottom face, right? And that's the face to which some of the nuts and bolts have been mounted. And we see that it has the hole pattern now for the large motor. And so that's how we can use, oh, positioned it a little bit too close here, and so it created that cut. So that's how we can use configuration with smart components. Okay, back to our presentation. So again, it asks us to select a particular configuration from the configurations that we predefined in our training assembly when we apply this smart component. And so that's the end of part 2, exercise 1. In part 3, we're going to look at auto-sizing the diameter of our smart component using a concentric mate. So this is a special part of smart components where if you mount something using a concentric mate, so we can think about, let's say, a gear on a shaft, a pin inside of a hole, something like that. Anytime there's a concentric mate, then we can drive the selected configuration of the smart component using the diameter of the reference that we selected to define the concentric mate. So the diameter of the shaft, the diameter of the hole, that can be used to drive which configuration of the smart component is selected. So here we have 3 configurations of this hand wheel, right? So we have small, medium, and large. And when we add this hand wheel, we're going to say that we'll use the large configuration when the diameter is within this range. So 1.875 inches to 2.152 inches. We'll use the medium configuration of the hand wheel when it's within this range, and the small configuration of the hand wheel when it's within this range of values. Okay. So in this example, we're going to open up the training assembly or the teach assembly. And here we have this hand wheel that has, again, those 3 configurations that's been mated into this assembly, and it's using a concentric mate. So we're going to come here to hand wheel, here tools, make smart component. And in this situation, we're going to select auto size diameter, and it's going to ask us for that mate reference. And so that face in there that we used for mating, and we have our configurator table. And so we can copy these values into here. So 1.8, oh, there, 1.875. And here will be 2.152. This is 1.375, 1.625. Okay. So we've defined that we're going to use the large configuration when this reference has a diameter between these two values. We'll use the medium configuration when this reference has a diameter between these two values, and we'll use the small configuration when this reference has a diameter between these two values. I'm going to go ahead and press OK. And of course, we need to save our smart component. So now let's go ahead and apply that smart component. We're going to come in here and open this assembly. Okay. And I'm going to drag and drop that wheel into place. And there we can see it is aligning for a concentric mate. And based on the diameter of that shaft, it is using the small configuration. And if we go here to this larger shaft, it's using the middle configuration. And here, because the shaft is even larger diameter within that range that we specified, it's using the large diameter. Now, clearly the orientation, we probably don't want these things to be oriented that way. I could go in and edit those mates to flip them. But what we're seeing is the small, medium, and large based on that concentric mate diameter. It's what's being used to drive the size of the smart component added into that assembly. And so that brings us to the end of part 3, exercise 1. Just to note that this is a hands-on session at 3D Experience World 2024. The conference proceedings will come out probably sometime in March. But of course, you can download all of the hands-on session materials by going to www.solidworks.com, introduction_smart_components. There'll be a YouTube video of this presentation as well. So everyone, thank you very much for viewing my presentation on smart components.